All right. Hello, everyone. I'm Patrick, and I'm here today with Andy, and we will talk about the state machine in Neuromore Studio. So let me jump over to the studio. All right. If you have any questions, just post them in the group chat, and we will try to answer them or go into details or something like that. All right, so we're looking at the studio. That's how the studio looks like once it's opened. And as we want to look at the state machine today, we will get rid of most of those windows. And
it might be handy, mate, to maybe do like a quick 2-second intro of the classifier too, mate.
Yeah, absolutely.
Didn't make it last week.
Yeah, so last week we covered the classifier, and with the classifier, in a nutshell, is basically about getting data in, classifying it, doing some calculations, doing some DSP, something like that, and then get some some output of the calculation. So to reiterate on that, usually we feed in either an EEG device, it might be a heart rate, accelerometer, gamepad, or something else. Then we do some mathematical operation, or we do some signal processing like an FFT, and that results in a one or multiple results, and those are represented through a custom feedback node. So it's kind of like raw data in one or multiple different modalities. We can have different channels per modalities. Then we do some DSP, some calculation. For instance, that we say, oh, we do an FFT, then we extract a dominant delta frequency, and then we calculated that at the end. So does it cover what you meant, Andy?
Yeah, mate, I think that's perfect.
All right. So that's kind of like the world of the classifier, one or multiple input data streams, some calculations, some DSP, and then there's some one or multiple results, kind of like what we call custom feedback. In that current example, it would be dominant delta, for instance. So pivoting into the state machine, now we have the dominant delta frequency with that particular example. And now the question is, what can we do with it? So in terms of end user interaction, what a user can see and so on. And to cover that and make that easy, we created a state machine. So we will look at the classifier later on, because state machine and classifier can also talk to each other, update each other, and so on. To create a new state machine within your file system, you see here, that's my personal folder. If you look into the studio, you have your own personal folder. What I did, I created a folder in here for the state intro for today's Q&A session. I already created some things, but let's start fresh and say, oh, we want to have a new state machine, and I call it Andrew's state machine. All right, there it is. So in the world of the state,
just out of interest, mate, like there might be people in here who don't have an idea of what a state machine is. So maybe just on a high level. So we've got this classifier thing which can do mathematical calculations on hardware devices, which is our classifier down on the bottom of the screen. So just generally, what is a state machine?
The state machine consists of, like the name says, of different states and transitions in between those states. To give an example, we have always a start and an end. And between the start and the end, there can be one or multiple states. Like I'm just dragging them in. So we have start and end, obviously, that only exist or should exist once. We might have multiple end states, though. Then there's certain action states in between. I will maybe later talk about the sync state and then the timer state, but the main focus is on those action states.
And so what do we use these for?
We use these to trigger certain actions and to do some modifications to the classifier to ask the user certain questions and so on. I think it's easiest to show an example.
Sounds great.
So I just connected that. So with the state machine, you see it's kind of like drag and drop. You can connect stuff. You can visually combine it. If you want to delete certain things, right click, remove connection. You can remove a particular state. So that's also pretty simple. So let's connect that. Nothing really happens. We have a state machine with 4 states: start, 2 action states, and the end. So let's save that particular one. And now if we right click on start, we can activate. That kind of like means go to that state and activate it. So like expected, nothing really happens. It started, it triggers that one, and there we are. If you want to reload the state machine, kind of like reset it, you can always do that using that resync engine. So that completely resets the state machine and starts it from scratch. So it's pretty boring because currently nothing really happens. There's no conditions on the transitions yet. So the results of the state machine are being shown in the experience window. So let me track that in. So there we go. That's the experience window. Let me move that down here. Let's get rid of that. All right. So what we can do with those action states, if we click on that state, we see different properties that state has. The state has a name, like default is action. There's a transition mode. That transition mode means if there's multiple transitions out of a particular state, it's like here, the transition mode means which of the transitions should be used. Default is select highest priority, and if you click on the transitions, you see there's a priority that's inside the transition, as well as the transition time that can be changed. So all of those action states have particular on enter action and on exit actions. So if we click on add action, we have different options in regards to actions that we can trigger. We can play an audio file, we can pause an audio file, we can seek in an audio file, we can stop currently playing audio file. We have the same functionality for videos. So we can play a video, we can stop a video, we can pause a video, we can seek within a video. We can show a particular image, we can hide an image, we can show a text, hide a text. We can set the background color of the experience window. We have the ability to send commands, and commands here, it's pretty technical. The background for that is that for most of the consumer-facing applications, like mobile applications that are being created using neuromore and the neuromore engine, they run mostly in iOS or in Android. So using that command, we can call particular functions programmatically in the iOS and Android application. Then there's parameters. And that option or that parameter action gives us the ability to change a particular parameter in the classifier. So right from the state machine into the classifier, update a particular parameter. We will cover that later. And then there's clear buttons. And that means that all the buttons that are being displayed in the experience window will be removed. So let's do something simple and say, show text. Hi, everyone. So now there's hi, everyone. We save it. Let's start it. And there's the text. And then it disappears once we reach the end. So an example for that is if we use audio files. I prepared something, is that particular state machine. We don't save it. Now let me, well, I guess you guys don't hear it. Let me try to switch to that one. All right.
Welcome to neuromore. Breathe in slowly, breathe out.
So what did we do here? It's a state machine that currently has 4 states. Welcome, place an MP3 file. It's just hosted online. So audio URL, what you put in here is any URL, HTTP, HTTPS that has an audio file, and then it's just being played. When the state machine is loaded, all the audio assets are preloaded, so they can be triggered immediately. So the state machine has not to wait until the download is completed. If you do not want to use that functionality, you can also check allow streaming. You can choose to loop forever, or you can set the number of loops that you want to have. And now in here, in that transition, we added a particular condition, because once we enter that state, we want to stay in that particular state, in the welcome state, and leave that welcome state once the audio reached an end. So what we're looking here at is now the transitions. And those transitions, so states have on enter actions and on exit actions. And the transition has certain conditions. So if there's no condition, we already covered that, then the state chooses select highest priority, or randomly just chooses a transition based on that setting. But once we add a condition to a particular transition, then of course that particular condition has to be true. And now if we look in here, we have a time condition. And the time condition means trigger that particular transition after certain time has elapsed. We can also randomize the time between a minimum and a maximum value. What we can also do is feedback condition, and a feedback condition, it's pretty great, because the feedback condition gives us the ability to query all the feedback nodes, like that dominant delta node down here, from the state machine, and let the state machine choose a particular transition based on a particular feedback value. And we have a button condition. So the button condition means that a button is being displayed in the experience over here. And I would say I show an example for that. So let's open that one, and let's open that one. Yeah, wonderful. So what do we have here? We have a state machine, we have a start state. There's a particular condition time. Let me see that. That's not the complete one. State machine set. All right. My preparation is not there anymore, but it's great for you guys, so we can create it from scratch together. So the first one is, the first condition is here. We want to make that transition once the time is greater 0, which means the session has been started. So we have that session control down here. And for that condition to be, so we are able to use that particular condition, we need to have an output name that's called time. So we're gonna create it, and we call it time. And what we do here is we take the session info node and we feed in elapsed time there. So let's add some more debugging. All right, so using the feedback window that I also just created, now we see the particular value.
So on a
of
higher
time.
level, mate, what are you doing now?
What I'm doing now is querying or creating the connection between the classifier and the state machine. So what I did is I used the session info node to get the elapsed time within a particular session, and then output it using a feedback node that's called time. So if we do that, you can see once the session is started, time starts going up, and it's not ranged. So let's do it again. And we see feedback time is getting bigger. And what we also see up here, so now once I press play, that transition is being triggered and we end up here in that particular state.
Okay, so if you wanted to start transitioning after, just say, two or 3 seconds, can you show the guys how to do that?
Of course, if we want to transition after you want to transition 2 seconds after the session started, then we just change that value to 2.
Beautiful.
Because the test value is test function is feedback creator test value. So that becomes true once the time is greater than 2. Let's save it. Let's press play 1, and there we go.
Beautiful.
So we also have other test functions. We can, if the feedback value needs to be greater than the test value that we entered, greater, equal, and so on. I think that's a pretty comprehensive selection of different test functions.
Yeah.
All right, now we are that particular state, and we have different.
So I hope everybody's seen it. This is a bit like a choose your own adventure book. Like the states.
Yeah, exactly.
The states are like places inside the user interface, or they could be, triggers that you might trigger some audio. And so you really get to kind of move the user around with this technique with very little effort. And so, I've talked to some of you inside the meeting about how you might like turn on maybe some, different lighting, and we'll probably cover that like we might interact with different hardware components, like outside of Neuromore Studio. And so hopefully you can see some of this inside the state machine. So like as you're going through here, maybe your delta does this, and then or your beta or theta does this, and then you're going to turn a light on, just say, and it's just super easy to use. And
yes.
we can cover all manner of things with this. So this is the same technique that we've used to develop therapies. And so from a very high level, it's extremely powerful.
Yeah, absolutely. So we figured out the first one. So we successfully queried that particular time feedback node and moved over here. So what did I create? I added a signal generator, and you guys can see down here, it's a sine wave, pretty simple. And the result of that sine wave is being outputted using a custom feedback node called sine. So what we're doing here, we have a transition and it's sine greater than 0. Then here we have a test smaller than 0. And within those states, we either show a text below 0, greater than 0. We jump in here. Then that transition tests if it's still running. Then we go back to that particular state. And if the session has been stopped, then we end that all. So let's reload it and press play and see what happens. All right, and as you can see, it's pretty nice to debug. You can always see what's happening. If conditions are true, then they become green. If they're not true, they become red. And now we have that like endless state machine that tells us if the value of sine is currently below or if it's greater than 0. It's a super basic example. Yeah, I believe that really shows how to query from the state machine what's happening in the classifier. And of course, instead of the signal generator with the sine wave, that could be heart rate, that could be heart rate variability, that could be the skin temperature, that could be skin resistance, it could be a dominant frequency, it could be like a difference in EEG, like in amplitude, it could be kind of like an increase in alpha, it could be and so on. So
or it could
the
be an
sky's
increase
the limit.
or it could be the theta beta ratio, like which Raj just asked in the group chat. So hopefully, Raj, this kind of gets to a point where it might answer that question, mate.
Yeah, absolutely. And now if we press stop down here, then we end up in the end state. So that's kind of like one way that's querying the classifier from the state machine using particular conditions on the transitions. Now we can do something else as well. Let me pull that up. Just that one and that one. All right, what do we have here? We have a start state. There's no condition, so it right jumps in here. That state shows a text. Choose a number. And choose the color as well. And then here, those transitions all have a button condition. So I see button condition 2, button condition 3, and once you have, once you're in a state that has outgoing button conditions, then those buttons are automatically displayed in the experience view. And what are we doing? So if I'm clicking here, well, then that transition is taken and finito. So what happens in those particular states? In those states, I'm going ahead and saying, oh, I wanna do a parameter action. And I take the parameter, I just randomly call it like P22. And what it does, it writes a particular value to that parameter in the classifier. So let me visualize that. Here we use the view node to visualize that parameter. To see what's going on, we add that signal view. So we see currently that particular parameter is set to 0. It's initialized in the classifier to 0. Now we're in that particular state, and when I click 1, and you see that in the classifier, that parameter has been changed to a 1. You can also go back and like set a 2 and so on. So that's a beautiful way to write data that the user entered in the experience window through the state machine back to the classifier. So to recap here, to write to the classifier to change parameters, and that parameter action just means it's a parameter node down here. So it's an input node parameter. You can drag in as many as you want. They need to have a unique name, so they can be addressed from the parameter action in the state machine. And what we're currently doing here is we set a value, kind of like an equivalent to the test function that we had for the transitions. And here for the feedback condition, we had test functions. For that particular parameter actions, we also have functions, and those functions determine what happens to that particular parameter. So I can set a particular value. That's what we're doing here. I just enter the value here and I set it. I can increase by a particular value. I can decrease by a value. I can scale by a value. I can let the state machine set that parameter to a random number out of a particular range. We can set that parameter to the value of another feedback node that's currently there. good example could be if a user says, "Oh, right now when I click the button in the experience view, I want to store my current dominant alpha frequency." So push button then would mean parameter last could be called last saved dominant alpha, and then we would just use the feedback value, and that can also be done with all channels. So that's in a nutshell kind of like the writing back to the classifier, setting parameters from the state machine. To show you another nice example what can be done with the state machine, I have that one prepared, and yeah, I guess you can hear the sound. So we're playing multiple sound files simultaneously, and the state machine fully synchronizes them. So those are all different audio snippets. They come from a music creation library, and you currently see, oh, there's all the snares and those wipes and so on. And then there's also an Anthony state, and that's kind of like the voice that we currently hear playing in the background. So that's kind of like a fun example to create music, and then you can of course make that music also to react to a particular user. So you can add snares if you hit a particular threshold, you can remove them, so you can create a fully interactive soundscape for with that. Another example that we have is not with sound, but let me pull that up, the light.
So you could almost do that with like beat matching heartbeats or something like that too, mate, couldn't you?
Yeah, you can do that. Absolutely.
Yeah.
So another example, that's a video, pretty simple one. Let me start that. All right, we have kind of like also an audio, so in the state machine, it's a pretty simple state machine. That state machine plays an audio file and then also plays a video file. And you can see that within that experience window, now the video is being played. So that could also be video snippets. They could be combined somehow. Same here, kind of like the sky is the limit, and you should be able to fully express your creativity. So let me pause here real quick and ask if there are any questions. Is there anything that you guys would like to see covered or have covered right now in a little bit more detail? I can also reiterate on Raj's question. So like Andy said, we can use the state machine to trigger certain cues and say, oh, now you're doing good, or no, like focus more, something like that. Usually what we see is for neurofeedback purposes that we have a combination out of the state machine that guides people through kind of like the session. So using the state machine, you can fully model the flow of your neurofeedback session, and from the beginning to the end, you can show, welcome user. Oh, the signal quality is bad. Please make sure that that your electrodes are placed correctly, that there's enough gel, or like depending on the setup that you have. Walk a user completely through it, kind of like automate it, and let the state machine do what a trained operator or a clinician would do, kind of like to replace the person that sits right next to the patient and automate the complete session. For the training itself, if we like you asked for like theta beta ratio, we would output that and use it to either control the volume of a particular audio, so we have immediate feedback, because the state machine is kind of like it's black and white. It's kind of like binary, you know, like we either play it or we do not. But to have that training experience, we would on the one hand give constant immediate feedback using audio, and on the other hand we would use some of the visualizations that we have. And in regards to visualization, there are currently 3 different games. They are also available on our releases section on GitHub. And you could also use video. So on mobile devices, we extensively use alpha channel for videos, kind of like keep the video vivid or mess around with the color channel, or keep the video colorful, you know, to have different tasks that the patient has to do and can do and interact with the system.
Did you want to cover some of that, mate? Like, did you want to show some of the experience stuff in more detail, other than the audio and video in this session, or in a future session?
I will cover that in a future session with the visualizations, to do kind of like the full like neurofeedback setup. And I show, oh, that's what we have. Those are the visualizations and so on. Okay. Shane asked for the sync state. So the sync state allows us to, let me jump back to that one. The sync state allows us to synchronize different states because they can be we can have multiple states being active, and to synchronize them, you can just feed multiple states into that sync state, and that makes sure that all the concurrently running states will be synchronized at that particular point, and then you can move on. There's different sync modes: wait for all incoming transitions, or wait for X incoming transition. You can say, oh, I'm fine if 2 of the 3 incoming transitions arrive, or you can say you want to wait for all of them in the transition mode again. It's kind of like leaving that particular sync state. To cover the last one as well, we have a timer state. So you could run that simultaneously, so you can have different graphs, you know, like running in one state machine. With that particular timer, do that. So with the timer, we have an interval, start active, entry mode is like start timer, restart timer. You can toggle the timer. You can choose the loop mode, if it should loop forever, if it should only loop a couple of times. How many times it's being looped, and yeah, you can use that to trigger certain actions after particular time elapsed. Yeah. Matteo, there's a neat way for that. Once you do that, if you use the command function, it's currently not implemented in the neuromore studio, but it being open source, it makes it very easy, you know, for you guys, and of course also for us to do some changes. The command action is really made for that. So I could see that in that command action, that you simply add the URL that you want to call, kind of like a REST API call, and then trigger a particular HTTP request, HTTP post request, or something like that. So I would simply use that command and add a tiny little code snippet then that does that HTTP request. For iOS and Android, we already have it part of our application framework that we will also cover in one of the upcoming sessions. potentially down the road, in addition to that command action, we could also think about just adding an HTTP or request action to it. That could also be something that we do down the road.
Yeah,
But as of now,
I really like the
yeah.
idea, mate. I think it's a great idea. Yeah. Because we do have, just for everybody like who's here as well, we do have like an output to OSC for the guys who might have missed it last week. So as part of the classifier, you can have inputs and outputs going to the internet. But yeah, it's interesting that if you wanted it as part of the state machine, that's something that we should definitely chat about more.
Yeah, I'll quickly show the OSC output that you just described, Andy, real quick. All right.
So yeah, and I just wanted to mention too that we now support LSL because of a kind user who wrote some open source code for us. So now we integrate with a whole bunch of new headbands and things, which is great, and it also means that we can input and output LSL as well.
Yeah, so we have here OSC input and output. So if I would like to output my beautiful sine wave that we have here via OSC, just have that OSC output, and then I connect it here, and now the studio streams OSC. So on the pass out /0, and of course you can change it in here, the OSC address. Now that data is being transmitted in real time. The
Actually,
settings.
Did you mind just quickly just describing that? So the OSC address, what's that?
So with OSC, the OSC address is kind of like a pass. So kind of like with OSC, you can look at it as like a key value thing, you know, and the OSC address is kind of like the key. So.
And so it's like a destination on a server, isn't it?
No, it's not the destination. It's the key, the configuration for the destination. And I guess I need to change how I share, because otherwise you guys won't see. I just share my whole desktop real quick. Because then you will also see the windows here. So here in the settings, OSC server, that's like input UDP term, local endpoint target host. That's where we determine the target host, the IP address for OSC, and the target UDP port. So that's where we set that.
Okay, great. So just for everybody who didn't see that last week too, is so OSC is a protocol like TCP/IP or UDP or those types of things, but it's super fast, and it runs on UDP, which can be used to like punch firewalls and stuff like that too. So that's kind of why we chose it, because it will allow us to do a lot more kind of interesting things online. Now, like the address there that Patrick's just shown us is almost like a it's a server that you need to kind of like contact, but it could be this server as well. So like the 127.0.0.1 is obviously it's your local host, or it's your local IP on this machine that Patrick's using, but it could definitely be anywhere where you could send that stream of UDP packets.
Exactly, yeah. So that that localhost 127 would enable me to open an OSC server on my local machine and then just receive those packages.
So if I had a Raspberry Pi in my local network, would it be possible for me to send information to that Raspberry Pi, and for that Raspberry Pi to collect that information, maybe turn on a light, Patrick?
Absolutely, absolutely.
Yeah. So Shane, hopefully you're starting to see how easy this could be for you to work. And guys, if there's any other questions, like, you know, in terms of like connecting things or working with the state machine, yeah, please ask.
Yeah. There's also something new that we added to the most recent studio release. It's a new window. It's engine status, and that engine status gives us all different kind of performance information of the studio, engine, device management, OSC message router. We look at latency and so on. And why am I bringing that up? You also see networking. We see connected clients. Those would be our visualizations, for instance. And you see the OSC server status. You see the registered receivers. You see a packet receive count, RX, TX, and so on. So that will help you a lot to debug in case you're having issues connecting the Raspberry Pi and kind of saying, oh, what's going on? You know, are there any packets like going in, going out, and so on.
So mate, there's a question. There's a question about mobile phones. Now I think we're going to cover that in a future tutorial. Yeah.
Yeah, we're gonna cover it in a future tutorial. Absolutely. I can bring up the slide real quick for you, Matteo, from our last session. Please bear with me for a few seconds.
And so the studio is kind of one kind of view into the neuromore software, isn't it, Patrick?
Yeah, absolutely.
And so there's this thing that the Patrick just showed us, which is the neuromore engine status. Now what's that, Patrick?
Yeah, I'm bringing up that slide to visualize it. So that's a slide from our last week's, or not last week's, but from the last Q&A session. So we have 3 different components in the neuromore platform. We have the neuromore studio. That's kind of like our graphical development interface that we're looking at. We can create configurations in terms of classifiers and state machines. We can run things and so on. So the classifiers and the state machines are being stored in the cloud, in the neuromore cloud. And we can see that here is like a backend file system. So all the classifiers and the state machines that you create will be stored in the cloud. That comes with many benefits like revisions. There's a versioning every time you save. You can work as a team on it, like collectively. And it also enables us to stream those classifiers and state machines from the neuromore engine that's mostly put in iOS and Android applications. So neuromore studio, research, development, professional use cases. But if you create a B2C product, then most likely the end user, the customer, consumer, will interact with your offerings through a tablet or mobile phone. And that's what we have the neuromore engine for. It also sits in the studio. So the neuromore engine runs the state machine. The neuromore engine runs the classifier. It does all the calculations, makes all the decisions and so on. And that particular engine can also be put into a mobile phone, iOS, Android application. We have different libraries for that, frameworks depending on the platform, as things are being called. And yeah, that's how an end user would interact with classifier, state machine, or Matteo, how you asked it. It's kind of like how the state machine or classifier is being deployed. I wouldn't necessarily call it deployed. It's more that the cloud has the most recent version of the classifier and the state machine, and then the mobile applications, the consumers, they stream the most recent state machine. So it's more a streaming client, you know. I hope that that clarifies things at least to a certain extent. But we will definitely cover that whole realm of neuromore engine, iOS, Android, and so on in way more detail. All right. Do we have any other questions? It doesn't sound like. All right. Yeah, I think that's it for today.
Fantastic.
Thanks, everyone. We will well, maybe the last question. What would be a topic that you would like to see covered in the next Q&A session? Because it's important for us to cover the stuff that matter for you the most. So.
And Raj, I was going to ask, mate, did that also did that answer your question? What Patrick covered as well?
Raj is not no longer in, so
No longer in the chat. Okay.
let's assume yes.
Yes. Yep.
Alrighty. Thanks everyone. Have a beautiful day, afternoon, evening, and yeah, looking forward. Yeah, wonderful. Like good
Oh, that's a
point,
great idea.
Marco.
Yeah. We'll definitely do a how to create a note session. Yeah.
All right. It looks like we have a clear winner. You know, it's all about creating notes.
Fantastic.
Lovely. Thanks everyone. Take care.
Thanks,
Stay
guys. Have a great
healthy,
one.
and looking forward to seeing you soon.